and welcome to another math tutorial. To finish out this first chapter or unit on linear equations and functions, we're going to look at solving systems of equations. In section 1.10, we're going to look at 2 by 2 linear systems, and we're going to present a couple of solving techniques that you probably are a little bit familiar with already, and those are substitution and elimination methods. So when we are talking about a system of equations, what we mean is when the two or more equations are considered together at the same time. And when we talk about solving a system, what we're looking for is the ordered pair set that solves both equations at the same time. So we're looking for the x and the y value that will satisfy both equations simultaneously. Okay, I'd like to start us out with the first example that we're going to do on a graph. Now, we're not going to spend a whole lot of time solving by graphing, but I want you to get kind of a physical interpretation of the solution as far as a single point that satisfies both equations. And I think that's easiest to see on a graph first, and then once we see that, we'll just move on to some algebraic solving techniques from there. So I've got two equations set together. We're going to consider them at the same time. We've got first y equals 3x minus 5. So let's put that on the graph. We've had some videos in this playlist already as far as graphing equations goes. So if you need to have a refresher on that, I encourage you to go check out those videos. But 3x minus 5 is going to start at negative 5, has a slope of 3 over 1. So a positive 3 slope looks like this. I'm going to get a point going this direction. Also, when I solve by graphing, I want to make sure that my lines are very accurately drawn. So I'm going to use a ruler to draw those lines on the graph. So there's y equals 3x minus 5. Now let's do the other line. Y equals negative half x plus 9. It starts at 9, slopes down 1, right 2. And you can see where they've already crossed each other. So if we connect these points. So there you can see I've got two lines and they do intersect. And it's that point of intersection right here that I'm interested in. That point is at 4, 7. That is the xy point that solves this equation and this equation. It's the only xy point that will solve them both. So that is the point that we consider the solution to the system. So when we go to these algebraic techniques for solving systems of equations, that's what we're after physically, is the point of intersection between the graphs of two lines. Okay, there are two techniques that we're going to use when we solve systems of equations algebraically. The first one is a substitution method. Now, with a substitution method, what you want first is one of your two equations to be solved for x or y. Okay? So that's kind of first step. Solve an equation for x or y. It doesn't matter which equation you choose, and it doesn't matter which variable you choose. So those are all free choices. You can choose whichever one you want. I'm going to always tend to pick the one that looks the easiest. The second equation's y looks the easiest to me because there's no other coefficient in front of that y. So that seems like it's going to be the easiest choice. If I solve this equation for y, I'll have negative y equals negative 4x plus 29. So I've just subtracted the 4x over, and then divide the negative off. It's going to make positive 4x minus 29. Now, after I have solved for x or y, in this case I've solved for y, now I'm going to substitute that equation into the other equation. Okay, so this y equation that I have, specifically this 4x minus 29, what I'm going to do with that is I am going to substitute it in for the y of the other equation. Like so. Now, once I have done that, I am going to just solve that equation for the x. Okay, so let's go ahead and do that. I'm going to start by distributing the 5. So we're going to have 2x plus 20x minus 145 equals 31. I'm going to combine my x's together to give me 22x minus 145 equals 31. We'll add the 145. So we'll have 22x equals 176. And we'll divide that by 22 to get x equals 8. Once I have that solution, now I'm going to plug it back in to the other equation. So let's take this, plug that back in. So we get y equals 4 times 8 minus 29. So y equals 32 minus 29. So y equals 3. So we have an x and a y value that solve both equations. You can leave your answer like that, or you can write it as an ordered pair point. So if you were going to graph these two lines, we have found that these two lines will intersect at the point 8. Okay, our next example problem, we're going to solve this system equations, but we're going to do it by what's called elimination method. Now, elimination method is sometimes called the addition method. Because what we're going to do is we are actually going to add the equations together. We're going to combine the two equations by addition. Now, when we add the two equations together, we have to guarantee that one of the variables is going to eliminate from the problem. Okay, so if I add these right now, 3x plus 2x is 5x, and 2y plus 7y is 9y. So neither the x or the y is going to eliminate as the system currently stands. So we have to do a little bit of manipulation to this system to make one of them cancel out, to make one of them eliminate. Now you can do this in any way that you see fit to make them cancel out, but essentially what you want is when you add that, like, the x terms are going to add to 0 or the y terms are going to add to 0. The only way to do that is to have a positive negative pair that are the same. So what I might do is look at the x's right here, and I could make the top x be 6 if I times it by 2. I could make the bottom x be negative 6 if I times it by negative 3. So what I'm going to do is multiply these equations, the top one times 2, which will give 6x plus 4y equals 4, and the bottom equation times negative 3, which will give negative 6x minus 21y equals negative 123. Now, if I add these equations together, 6 plus negative 6 is 0. That's the goal. That's what I want to happen. 4 minus 21 is negative 17y. And 4 minus 123 is negative 119. Now, I'll finish this by just dividing 119 by 17. And if I do that, we get y equals 7. Okay. Now, once we have our first variable solved for, now we're going to do a substitution strategy to finish this. I'm going to take this y value of 7 and I'm going to substitute it into either this equation's y or this equation's y. And it doesn't matter where you substitute it, you're going to get the same x value no matter which equation you choose. So choose the one that you think looks easier. I'm going to choose the top equation. So the top equation is 3x plus 2 times 7 equals 2. So I get 3x plus 14 equals 2. I'm going to subtract 14. So I get 3x equals negative 12 and x equals negative 4. So now I have an x value, I have a y value. That's what I need to have an intersection point. So my solution is negative 4, 7. All right, this next example problem, the directions just say solve the system. So you have to decide, do you want to do substitution method or do you want to do elimination method? Now again, for substitution, I'm looking to see, is it easy for me to solve for x or y in either equation? For elimination, I'm asking myself, is it easy for me to make these numbers the same but opposite sign, so one of them, either the x or the y, will eliminate? So which path do I want to take? And when I look at this top equation, I see that all the numbers are even numbers, which means I can divide them all by 2, and that would eliminate or allow me to isolate the y quite easily. So that's what I'm going to do. I'm going to take this equation and I'm going to start by moving the x over. So that'll give me negative 2y equals negative 6x minus 6. Divide everything by negative 2 is going to give y equals 3x plus 3. So I'm going to do a substitution method. I'm now going to take my 3x plus 3 and I am going to substitute it into the other equation's y. Okay, make sure you use the second equation on this step here. So if I do that, we're going to have 5x plus 11, and then the y quantity is the same as 3x plus 3 equals negative 81. So distribute that 11 gives me 33x plus 33 equals negative 81. Combine my x's to give 38x, and then I need to take that 33 and subtract it over. So let's see, if I subtract 33 from negative 81, we're going to get negative 114, and then divide both sides by 38. I believe we're going to get 3. Well, negative 3. Okay, so I've got my x solved for. I'm going to take that value, I'm going to plug it back into my original y equals equation that we found. So y is going to be 3 times negative 3 plus 3, which is going to be negative 9 plus 3, so y equals negative 6. My solution point is negative 3, negative 6. Okay, the next example problem is another system to try and solve. Again, do I want to use substitution or elimination? Looking at this equation, all these numbers, I don't want to divide them by 7 or 3 because they're not all divisible. And same thing here, they're not all divisible by 2 or 3. So doing substitution is going to create fractions in this case, and I don't want to mess with all that fraction work. Instead, I like this variable right here. I like looking at the y's. The y's are already positive, negative, which is what's required to have them add to 0. I just need to make them the same number. So I'm going to take the top equation times 2 to make that minus 6. I'm going to take the bottom equation times 3 to make that positive 6. So top equation will become 14x minus 6y equals negative 82. The bottom equation will become 9x plus 6y equals 36. Now I'm going to add these two equations together. The y's being negative and positive 6y are going to cancel. So it looks like we are going to have 23x equals negative 46, and divide by 23, x equals negative 2. Okay, now take that negative 2 and put it into either this x or this x, whichever one you think you'd rather solve, whichever one I suppose looks easier. I like the bottom one better. 3 times negative 2 plus 2y equals 12. That's negative 6 plus 2y equals 12. Add the 6. So we get 2y equals 18 and y equals 9. So our solution point is negative 2, 9. Okay, directions on this final example problem are to write and solve a system of equations to model the problem. So, problem says that at a local grocery store, Mr. Bernard, that's me, bought 5 apples and 9 bananas for a total of $4. Later that day, his wife went to the same store and bought 8 apples and 6 bananas for a total of $4.30. What is the price of an apple at the grocery store? So let's start with a system of equations. Let's make an equation for what I bought, and let's make an equation for what my wife bought. So I bought 5 apples. I'm going to use A for apples. And I bought 9 bananas, so B for bananas. And I spent a total of $4. My wife bought 8 apples, and she bought 6 bananas for a total of $4.30. Now that's my system of equations. All right, so now I have to decide, do I want to do substitution method or elimination method? Notice in this problem that I'm trying to find the price of an apple. So all I'm asked to do is to find A, my apple. I don't need to know what bananas cost to solve this problem. So I'm going to do elimination just because I don't see an easy way to make something substitute there. But seeing that I'm trying to solve for A, I'm going to try and eliminate the B, the banana, because that's going to leave A behind, and that's what I'm trying to solve for. So I have to make the B's cancel out. We've got 9 and 6. The least common multiple of 9 and 6 is 18. So I could make the top one 18 by multiplying by 2. I could make the bottom one 18 by multiplying by 3. And in order for them to cancel out, one of those 18s is going to have to be negative. So it doesn't matter which one. Let's just say we make that top one negative. So let's do that and see what we get. So negative 2 times the top equation is going to give me negative 10a minus 18b equals negative 8. And 3 times the bottom equation is going to give me 24a plus 18b equals, looks like 12.9. Okay, so we're going to add these together. We are getting the b's to cancel out. The negative 18 and positive 18b are going to cancel. So it looks like we have 14a equals, and 12.9 minus 8 is 4.9. If I divide 4.9 by 14, we get A equals 0.35. So the cost or price of an apple is 35 cents. Okay, that concludes this video on solving 2x2 linear systems of equations. If you have any comments or questions, please drop them in the comments section below. If you need to see additional example problems, please watch the next video on just a few extra practice problems for systems of equations. If you found the video helpful, please leave it a like, a thumbs up to help support the channel. I'll see you in the next video.